And one thing I don't quite like is this load model function. And what I don't like about this is that it combines a lot of stuff together, right? It loads the image from the file, it creates a texture for that, it loads the OBJ file, and then it creates the vertices and indices for that, and then it uploads it. So I would like to maybe procedurally create meshes, and maybe I want to reuse the textures and stuff like this, so I would like to split this one. Let's see, maybe it would make sense to have some kind of GPU file or module where we would have functions for uploading data to GPU. So basically all this transfer buffer stuff that we handle here is something that we can do there. So maybe we create a GPU Odin file, and let's see. Well, that will definitely need an SDL import. Now one thing that I definitely want to do is load multiple models in a one copy pass. So let's, instead of creating the copy pass here, let's just pass it here. So copy pass SDL GPU copy pass, something like this. And just take this out and move it outside here to the initialization, right? So we create the copy pass here, then we pass it here to this function. And another thing that we want to not forget is and submit it here. So this is something that we will do. Now, as I said, this uploading stuff is something that I want to extract as well. So let's maybe have a function like upload mesh, or even let's call it upload mesh bytes, because I want it to be generic and support different vertex structures and index buffer structures. So let's say that it will take a copy pass that will take a slice of vertices, which is just a slice of bytes, indices, slice of byte, and also we need the number of indices not depending on the actual byte, be it a 32 or 16-bit integer. We want it for later for rendering, right? So we will say num indices is int, and that should return a model, except that the model is actually also having a texture, and I would like to split those so I can reuse meshes with different textures, or the same texture with different meshes, right? So let's actually rename this to mesh and have it like this. So the vertex buffer, index buffer, and number of indices, that would be a property of mesh. And then we have a model which will have a mesh inside of it for now, right? And for backwards compatibility, we can also say that it's using this mesh field, which means that all these fields, vertex, index, buff, and num indices, will be also available in the model, even though they are part of the mesh substructure. This is temporary, but yeah, maybe we should add a to-do temporary using. So let's continue with our uploading. So what do we want to extract here? So this vertices and indices is something that we get from OBJ, but all this stuff is actually part of the upload procedure. And we don't need this anymore because we know that size in bytes is just length, because we are passing the byte slices and not some other slices. So this is fine. We create the vertex, index, and transfer buffers. We copy the memory. For that we need the mem module. So we cut the actual uploading as well. So that should be fine. We can release it as well here. So that actually returns mesh now, not the model, right? And that should basically just return the vertex buff that we created, index buff that we created, and the number of indices that we passed. And here we can of course convert it to U32. So this is all nice, but I don't want to actually cast it to bytes all the time and calculate a number of indices. So what I want to do is basically just have an upload mesh generic function, something like upload mesh procedure. It will take almost the same arguments, but the vertices will be a parameterized type and the indices will be also a parameterized type. I don't know, let's call it S. And this is not needed. And what it will do, use the slice API to just call the upload mesh bytes function, like copy pass, and then we use slice to bytes. So that will just convert a slice of anything to a slice of bytes. So vertices slice to bytes indices, and for the length we can just take the len, because that will be a slice of proper elements, so len of indices. So that's a nice helper function that we can use here now. So we can say mesh equals upload mesh copy pass vertices and indices, and instead of all this we just supply them mesh as is. Let's see if that still works. Yes, it does. So pretty nice, right? Now let's take another look at the textures. So for texture we do similar stuff. We create a GPU object and then we upload it via the transfer buffer. So let's keep this for now, but separate it from actually loading the pixel data. So let's make a new function like upload texture. That would be a procedure that takes a copy pass and then just a slice of bytes of pixels, and then a width and height as U32, because that's what SDL wants, and that will simply return a pointer to SDL GPU texture. And the code for that, well, it's basically this part where we create it. That would be width, that would be height. We can return it. Then we do all this stuff. So we create a new transfer buffer. This one can be just now length of pixels because we have a slice of bytes. Same here. And because of this is a slice and we want a row pointer, that would be row data of pixels. And those are just width and height. So we create the texture, we upload it through the transfer buffer, release the transfer buffer and return the texture. So now we can say somewhere here the texture is upload texture, copy pass, pixels. We need to create a slice for the pixels, right? And for that we also need to use the slice module, and we can use a slice bytes from pointer, right? And the pointer is our pixels and the number of bytes is pixels byte size, so like this. And finally we have a image size that we got as I32, but we need to convert it to U32, so image size X and then U32 image size Y. And yeah, this needs to be just an int, so something like this. And by the way, we never free those pixels, so maybe it's a good idea to call STBI image free, and that would be pixels. Let's see if that still works. Yes, it does. And finally, I would like to separate this function also in two. One for loading the mesh from the OBJ file and one from loading the texture from the image file, right? So, and I'm thinking that this is also a part of a separate kind of module, which could be something related to assets, right? So you see it's shaping up a little by little. So let's create something like asset Odin. Let's take the load model here, update the import. STBI is only needed here now. SDL is definitely needed everywhere, so we need also file path, strings, and slice. So this can go as well. Strings is probably also only needed for the assets, and the same with slice actually. So now our game structure looks pretty nice. It only has all the game behavior logic, but as I said, I want to split this function in two as well. So let's maybe have something like load texture file that will take a copy path and the texture file and return SDL GPU texture. And we will just take all this stuff, place it here, and return the texture, right? So basically this texture is load texture file from this copy path, texture file, and this stuff is basically obj loading. So let's create something like load obj file using the arguments, remove the S1, and this would be our, well, mesh, right? Let's take all this stuff, return the mesh. Mesh is load obj file, copy path, mesh file, and you see it still works, still feeling pretty good, and it looks a bit cleaner, right? We can clean up some imports here, and you can see our code is a bit more modular, a bit more easier to read and understand, hopefully. So let's commit that as well. That would be extract asset loading and GPU uploading, something like this. And now when we have this, we can actually try and, for example, draw multiple objects instead of just one. And we can do this in a single render pass using the same pipeline, but we would just use different models and also maybe different model matrices. So let's take a look at what we need for that. Well, we need some notion of entity, I guess, right? So let's say entity, that would be a struct that will have some reference to a model. Maybe we will have a global table of models. So let's say that the entity has a model ID or something, which will be, well, let's maybe introduce a type for that, model ID, and this can be maybe just a distinct integer. So if you don't know, the distinct integer is basically the same as integer, except that it's not assignable from and to integers, so it's like a separate type, while the underlying type of this compile time type is just int. And this is good for like type safety and readability, so this is nice. Let's have a model ID. What else? Let's have a position, so we can have multiple positions. And yes, since we are rotating, let's have a rotation as well. And actually, let's use quaternions for that, like grown-ups. So let's introduce a proper quaternion type for that. Thankfully, with linalc, it's very easy to use. Let's have something like quat, and we need a F32 quaternion, which is this type, right? 128. So basically, it's 4 numbers, 32 bits each, so 128, and we will have the rotation as quaternion. So that's pretty good. Now we can probably remove all this stuff, and instead we can have a table of models. Let's just have a normal slice for now. We can maybe have a proper asset management sometime later, but this is really, for now, completely out of the scope of this series. So I will just have a model slice like this, and then I will have an entity slice. Now back to here. Well, we want to allocate a slice here, but since I don't want to really create any kind of dynamic loading system for now, what I will do is simply say g models. That would be a clone of a local slice, so something like import the core slice, something like slice clone. That would be just a local slice that we are gonna clone and allocate. And that will, for now, just contain one model. And actually, maybe we can also load the sedan model as well. So let's do that. Sedan sports. And one thing that we don't really want to do is load the texture once again, so we should probably load it before separately and just reuse. So let's say color map, that would be our load texture file, copy pass, pass it here, and well, we don't really want to call the load model, right? We want to just construct the models from loaded mesh. So like loaded obj file and the texture that we have, so color map, right? Something like this. And I guess I will do the same with entities, so let's have a couple of entities. Now let's just have one with a tractor model. Let's have it on a center position. And now for the rotation, well, we can say that it's linalc.quaternion F32 identity, but this is actually a bit annoying to write, and if we take a look, that is basically just 1. So the identity quaternion, by the way, exactly like the matrix, can be just a literal of 1 casted to the type. So because we know the type, we can just say 1 here. So that is pretty handy. I kinda really like Odin for all these small niceties that are really cool. Now let's have another one, which would be our sedan, and let's say that it's a little bit to the right, I guess, and maybe it could be rotated, let's say 15 degrees, right? How do we do that? Well, we can use another linearc function, quaternion from Euler angle y, so around the y axis, right? And we can use directly the F32 version. And finally we just say 15, but this should be radians, so linearc radians per degrees, right? Now let's see what do we want to fix here. So we don't have the rotation here. Let's just update the first entity that we have, right? And how do we do that? We say G entities, the first one, the rotation, but instead of adding it, we need to actually multiply it, because that's how quaternion works, right? We need to multiply the current quaternion with the rotation quaternion. So let's have another quaternion here, linearc dot Euler angle, so exactly the same stuff here, and just use this angular value. Now finally, this stuff should be done per entity, so let's move it here. And let's basically just iterate over entities and render all of them, right? So for entity in G entities, something like that. Now we can create a matrix differently now. So we can use linearc matrix 4 from TRS, which stands for translation, rotation, and scale. And we have the translation, which would be our position, so entity position. Then the rotation is the quaternion, that would be entity.rotation. And scale we don't have, so we can just put 1 there. So that would be our model matrix. Now here we use the model, right? And we can just have a local variable like model. And we need to get the model from our asset table, so G models entity model ID, right? And finally we just use it like this. And we should probably get rid of this generic load model function, because if we want to move further with a proper structure, we should probably load the texture separately and load meshes separately and then combine them into materials and whatnot. So let's remove this because we don't need this anymore. Let's run the game and see that we have 2 different models. So this is pretty nice. What we could also do is maybe add yet another object like this, right? There's ambulance, for example. This looks pretty nice. So let's maybe grab it. Ambulance, obj, just copy it to our folder, go to the init method and have yet another model with the same texture. Ambulance, right? And we can have yet another entity that would actually use the new model. Maybe put it to the other side and rotate it to the other side as well. And yeah, this is pretty nice, and this will allow us to experiment with lighting different objects, maybe with different parameters, so this is pretty nice. Now, this is in no way any kind of perfect structure, of course. We should probably improve this. The asset and entity management is basically non-existent, right? We just allocate them on the init, but at least we are able to render multiple objects now and load multiple models and textures, so this is pretty nice. Can maybe get rid of this using now, so if we remove this, we get some errors here because now we need to actually access the mesh properly as a field, right? So mesh this. Easy fix. So yeah, I think that's enough for now. Let's commit this. That's gonna be separate entities and models, something like this. And hopefully now we have a lot of breathing space to actually do some more complicated rendering, some lighting and whatnot, which hopefully I will do next time. And yeah, stay tuned.